morning everyone. Hope you're fine today. We're going to continue the lesson of the alternating sinusoidal current. Actually, we want to know the effective values of the current and the voltage. We have proven previously the AC equation to be I equal I maximum sine omega t plus phi. And that's the curve of this equation, knowing that if we consider phi to be initially 0, so we'll begin omega t is 0, sine 0 is 0, so 0. So for sine pi by 2 is 1, so I maximum. It corresponds to this one, I maximum. And for pi, sine pi is 0, so it will be 0. For the half of the period is positive. And then when sine of 3 pi by 2, it is minus 1, so it's minus. It's going to be minus the maximum current corresponds to this one in the negative region. And then we will have 2 pi, sine 2 pi, of course it's 0, so that's the complete period. So that's the positive region, that's the negative region of the second part of the period. However, what is the value of the alternating current? Before going to the value, let us examine what is the definition. I effective of the alternating sinusoidal current of I maximum is the direct current of the that dissipates the same amount of heat in the same resistor during the same interval of time, which is the period. It is actually given by I effective is equal I maximum over square root of 2. Similarly, for the effective voltage, U effective is equal U maximum over square root of 2. However, if we want to go another further step for the experimental and theoretical analysis of AC circuits, we have the current that we have proven, I equal I maximum sine omega t plus phi, and we have the voltage as well. However, if we want to study the first type of the circuits, which is the resistive circuit R, we have this circuit, we have a resistance connected to an alternating sinusoidal voltage generator. We connect the resistor and the generator to an oscilloscope. However, there is a rule that says that we have to connect each component, for example the resistance or the generator, to a phase component ground. Phase component generator and the ground. So the ground, we put the ground between the two components that are to be measured. So, and the current does not matter concerning its sense. However, in this case, if the circuit is resistive, phi is equal to 0. Why? Because you and I are in phase. Okay, how can we know that? When we connect this to the oscilloscope shows us this curve actually. And this curve represents the current traversing the resistance and the voltage traversing this resistance. We realize that the maximum point of the current, which is I maximum, and the maximum value of the voltage traversing the resistance, they meet at the same time. We're going to call this T1. We realize that when both of them are 0, they meet at the same time. And we realize that whenever the maximum voltage of the resistance exists and the maximum, absolute maximum of the maximum current traversing this resistance is absolute maximum, they both meet at the same time. Likewise at 0 and so forth. So this means that the current and the voltage are in phase because they simultaneously at the same time reach their maximum values, minimum values, and 0 values. In order to understand this in a more deeper way, for a phasor diagram, we have here the voltage. We have here the voltage of the resistor, which is confounded with the current traversing the resistor. So they have the same sense, same direction, so there is no angle between them. This means that phi is equal to 0. So in this case, phi is equal to 0. So between the current and the voltage, there is no phase difference. There is no phase difference. It's the same one, which is 0. Actually, we have Ohm's law for a resistor. U of R is Ri times Ri, which I is I maximum sine omega, so we will substitute it, R I maximum sine omega t. Have a nice day.